now so that we have a place that I can kind of go back to this later. So that should be fine. Just wanted to let you guys know so you're aware of it. And so here we go. As we're talking about this, um, when I talked about this in terms of seeking the truth, and I am going to put that up here at the top because I think it is kind of an important piece for us to look at. When we're talking about the truth, what I'm really looking for is the way that we're approaching what happens when we're talking about equations. Yesterday, we talked about equations versus expressions, and that with an equation, what you're trying to do is to find values of x that make this equation true. And so that's sort of the place that I want us to start from here. But as we're looking at this, what I want to make sure that we do is start from that definition we ended with yesterday. And so that if you write down the notes, this would be a good place for you guys to write them. But as we're doing this, what we said yesterday is that a solution to an equation is the x value that makes the equation true. Now, here's the thing. When we look at this, when we talk about making the equation true, I kind of dig the idea of truth in like your humanities classes like English and social studies because they're fun thoughts about saying what's true, what's not true, what is a half truth. And those are great thought processes to kind of go through. We talk about stuff in math. Truth is very black and white. Truth does not have a whole lot of gray area because we're talking about something being true. If I have the number 3, it's either equal to the number 3 or it's not. There isn't a whole lot of, well, it's kind of equal. No, 3 is 3. That's the way it goes. 7 is 7. That's the way it goes. 15 is 15. So we talk about truth. There's not a whole lot of places here that give us wiggle room for, is this right or is this not? What starts to be an issue is when we think about how do we get to what we're looking at. And so in the case of what we're talking about solving equations today, what we're going to be doing when we're looking for truth, essentially what happens for a solution is that a solution makes the expression, and I'm going to do exp for expression, on the left the same as the expression on the right. And this is what I mean when I say that, because most of the time, you're going to have equations that are going to be like 7x plus 5 is equal to 13. So I'm going to plug in a number that's going to make that expression on the left, 7x plus 5, equal to the expression on the right is 13. Sometimes you got variables on both sides. And so we're picking a number that when we plug it in, it's going to make both sides equal the same number. But at the end of the day, what we're going to be doing is evaluating an expression here, evaluating an expression here, and making them the same. I watched Mr. Kennedy. He's one of the other math teachers, one of the other algebra teachers. I watched his video talking about some of this stuff and sort of the way that he wanted to teach this. And I like being able to kind of look at what other teachers do and sort of use that. One of the things that he said is that as we go further on in the year, solutions get more and more complicated. And that's actually not true. A solution will always be the value that makes the equation true. What we start to make more complicated is the process of getting to that solution. So like today, we're going to be really just checking to see, is something a solution or is it not? Is this going to make it true or is it not going to make it true? What starts to happen as you add more things in algebra is we add more and more steps to that journey that we need to get to what the truth is. And so it's kind of like adding levels to what's going to happen in terms of getting to our goal. With this, most of what we're going to be doing here is going to be fairly simple. So I'm not concerned about it. But as we get to what makes it true, it becomes something that is, I think, pretty straightforward. It's just what value makes this equation work. So let me start off with an example to have us sort of look at it, okay? So this will be our example 1 for today, and we'll see what we're looking at for the truth. And a way that we can ask these at a simple level is x equals 3 a solution to 4x minus 2 equals 10, question mark. Okay, so when we ask for something like that, I'm giving you a value to see, is this the one that makes this true? Now, again, if it makes it true, it means that if I evaluate the expression at this value, then it should make that left-hand side and the right-hand side equal to each other. So that's what I'm going to be having to plug in to check. Now, our delta math problems are going to be very similar to this. And so essentially, what they're asking you to do is check. If I plug this in, I'll put a little question mark here. If I plug that x equals 3 in for my x, does it actually equal 10? And so when we put something like that in there, what we're really just saying is if I'm checking a solution, you take the equation, you replace the x with whatever you're checking for, and then you do the work. Now what they're going to do is put these little question marks there to say, right now, I don't know if it's equal. So we got to do the work on the left, we got to do it with the work on the right and compare it, see what we do. So let's just do some math. Y'all type it in the chat. What is 4 times 3 equal to? And Tammy, don't worry about like typing things. It's okay. What's 4 times 3? Yep, I got a 12. Uzziah's right. 4 times 3 is 12. Order of operations, we get 12 minus 2. Still don't know if that's equal to 10 yet. And what is 12 minus 2, everybody? 12 minus 2 is 10. Yay! So my question, does 10 equal 10? Of course 10 equals 10. So what I can say is, when I get to something like this, the question of 10 equals 10 is not even a question. I can say that this is true. So now I'm answering the question, is x equals 3 a solution to the equation 4x minus 2 equals 10? I plugged in the 3, I got the value 10, it's equal to 10, we got a true statement. So in this case, we can say that x equals 3 is a solution. We're answering the question that they ask at the very beginning. Now, this seems fairly straightforward, and it's because it is. All you're doing is looking. We have an equation, we have an unknown value x, we're trying to figure out what makes that true. Today, it's kind of like our baby steps in terms of going through this. What we're doing today is we're going through the process of how do we check to see if they are true or are not true. If they make it true, it's a solution. If they don't make it true, it's not a solution. That's kind of where we work through this stuff, okay? So most of what we're going to be doing is work just like this. Now, I want to give you another example just to kind of show you what it looks like if it's a little bit different. And so I'm even going to tell you for this one. If I give you a problem, and we'll call this example 2. Let's say, is x equals 1 a solution to 3x plus 7 equals 15? Okay, question mark. Now, if I'm checking that, and I'm going to tell you right now, guys, it's not. It is not a solution, but I want to make sure that we understand how we respond when we do get something that's not correct, okay? So when we're looking at something like this, what's my first step if I'm checking to see if this is a solution to 3x plus 7 equals 15? Somebody type in the chat what my first step would be in this case to check for the truth of this statement. What do I have to do? This is where I patiently wait as I record. That's right, I changed the x and I replace it with what number? Yep, I replace that with 1. So the one thing I do want to make sure that you do when you make that change, make sure you're using parentheses when you change x to 1, because the one thing I don't want you to do is to put a 1 there and say you're dealing with the number 31, because that does tend to be a pretty common mistake. And so we are checking, I'll put my little question mark there again. When I replace that x with 1, or substitute that x with 1, and I do all my work, does it equal 15? So let's go through and do the work. We do the first part here, that's the 3 times 1. That'll give me a 3. So 3 plus 7. Want to know if it's equal to 15. Somebody type in there, what is 3 plus 7? Anyone? 3 plus 7? Yeah, it's 10. So I'm asking the question, does 10 equal 15? No. This is clearly an untrue statement. So this is false. And so now I got to know what to do, okay? And this is the way that I want to go about doing this. If you get to a statement here that is a false statement, I want you to do two quick things. First, check to make sure you plug things in the right place. A lot of times these early ones we're checking and we know that the answer is going to be true. So we're going to figure it out. So I always go back and go, all right, did we plug it in right? We did. Did we do the math right? We did. We got a 10. Okay, so we're fine. It's false. Great. So the first thing you want to do is state that 10 is not equal to 15. The way you say that, you put an equal sign with a slash through it. It just means not that thing. So 10 is not equal to 15, which then means x equals 1 is not a solution. Now, we could find the solution, but that isn't what I'm asking you to do. I'm asking you to check the truth of this very specific value, and that's kind of the point. When we're looking at something like this, if it's asking is it a solution, your answer is going to be yes it is or no it isn't. And what you're providing me with is the evidence of your statement. No, it's not a solution because I showed you when I plugged it in it doesn't work. And in the one we had before, yes, 3 is a solution because when I plugged it in, I did get a true statement that 10 is equal to 10. And that's kind of the way that we go about doing this. Really, it's not super difficult, and this is the level of what it is that you're going to have to do. Now, I do want to show you one of those problems that does get to be a little bit more complicated. And I'm showing this to you not to frighten you, because I know that when things like this happen, people get a little bit off, and I don't want that to be the case, okay? So I want you to bear with me for a sec as I do this. I'm going to write a new equation here. This will be example 3. I do not believe you're going to be facing anything like this, but I would rather you see it in a situation where if you wanted to ask a question, you could go, oh, I see what's going to be happening here. So this will be our last example for today. And it's a little more complicated than what you're generally going to see. But if I say is x equals 1 a solution to, and then I'm going to write this equation. 3x plus 7 over 2 minus 5 is equal to 9. Now, this right here, this is a mess. There's a lot of craziness here. Let me cross that out so it looks better. Is x equals 1 a solution to that? Now, what is my process? How do I check to see if that's true? What would I have to do? Because I don't want to let that fraction sit there and frighten you away from being able to do the work, because I don't think this should be too difficult to do. But could somebody tell me what is my first step to check if this is right? What do I have to do? Somebody's got to write something. I'll give you a hint. Simone, when you answered that question the last time, you are answering how to do this every time. How do you start this process? You change x. You substitute for x, and that's what we do. And the thing that is interesting about this is that I gave you the same number to check with. How do you check with this? You change x to what value? To 1. It's exactly the same process. It's just that where you're plugging it in gets a little bit more complicated. And that's what we're going to work together to get to right now. I don't want you to get overly confused. We're still doing the same thing. I still replace it just like I did before. I just put parentheses there instead of that x. Now, guys, I know how much crap there is here to go through. But plugging a 1 in, that step is not going to be that much more difficult than just writing the equation in the first place. So we changed x, we made it a 1. Now I'm just doing the work one step at a time. So what I want to do is to say, all right, I'm going to do this stuff over here and see if I can get to 9. When I do this work, anything on the top of a fraction is kind of like a set of parentheses. So I got to do this stuff up here first. Let's just do it one thing at a time. So here, let's do the top. 3 times 1 plus 7. Well, we got to do the 3 times 1 first. 3 times 1 is 3. And I'm going to write the rest of it. Plus 7 over 2 minus 5 equals question mark 9. I don't know if it equals. But if you see what I'm doing here, every single thing that I do, I can see where it came from before. Here, that x became a 1. I can see that. Here, I did the 3 times 1. That became a 3, but everything else stayed the same. What's my next step here? What do I have to do next? Somebody type it in there. What do I do next? Anyone? Do I do 3 plus 7? Do I do divided by 2? Do I do minus 5? What do I do? I will tell you this. This is our last problem we're going to do. Somebody tells me what it's going to be. That'll help us get to the next step, and I will even potentially let you go early just by answering my questions. What do I do first? If you say something and you're wrong, it's okay. I'll tell you what it is. Yes, I do 3 plus 7. Hallelujah. Because that's still on the top. I haven't finished. 3 plus 7 up here is going to be 10. 10 over 2 minus 5. Does that equal 9? So now I've got 10 divided by 2 minus 5. Division comes before subtraction. So I've got to do 10 divided by 2. That is going to give me 5. I scared you with my voice. I'm sorry. Actually, I'm not sorry. That's kind of the way that I teach. I will tell you this. There are times in class when we do eventually go back there that I wait until it's quiet. And so I'm about to get loud, everybody. I want you to be prepared for this. Is the way it goes. So I get it till it's quiet. And then I start bringing my voice down. I start talking down here and say, okay, well, we've got to figure this out. We're not done with what's happening. Are we going to go through this? Like, what's going to happen? And so I get my voice down there so you're ready to listen to that. And then I go like this, and I go, so when we do the 5 minus 5, I got to get an answer. What's that answer going to be? So one of you guys is going to type it. This is going to be where we're going to go. Somebody type, what's the answer to 5 minus 5, everybody? What is that? I can't wait. And I'm going to see it. I'm about to get loud, I promise. So Ruben wrote the 0. A lot of people wrote 0. And then I go, yes, that is exactly right. It's 0. And so it's the change in the tone that scares the crap out of the class. I'll tell you, for me, doing what just happened there, I kind of keep score in my head. Like, I'll look out at the class knowing I'm going to do that. And what I'll do is see how many people actually jump. And if I can get the whole class, it's like a reward to me. And then I'll go out and buy myself like an ice cream at the end of the day to say, I made an entire class jump. That's great. It's the very best when stuff like that happens, because it means people are awake, and then there's all this like blood that goes to their body. They're like, oh, now they're ready to learn. Like, if I ask the question, does 0 actually equal 9? What can you guys tell me? Does 0 equal 9? No. Or even hell no, it doesn't. This is false. We can't get that. So if I say false, this is a false statement. 0 does not equal 9. You can say 1, x equals 1 is not a solution. And that's all we got to get to. And so, guys, the process is the same. You take a value and try to evaluate it. You see if you get something that is, in fact, true or false. If it's true, that's a solution. If it's false, it's not a solution. So we are testing the truthfulness of these solutions today. And that's what you're going to be doing when you go and do this work in Delta Math as well. So right now, this is the last part of what I'm going to be doing. I'm going to stop sharing. And I'm also going to stop recording right now because I don't think there's anything else that I need to do for this lesson.